Let's now calculate the derivative of the function. First, let's save a new script. Type in CLC, clear, and close all as we usually do. And now define again the argument of a function. From 0 to 4, let's say. Let's start with this. And then we will recall what the derivative is. The function will be sine of x. And the definition of the derivative we know from mathematics course. And it is a difference of values of function in neighboring points divided by difference in arguments in the same points when the difference in arguments in the neighboring points goes to 0. And this could be written as a y derivative is equal to diff of y divided by diff of x. Because as we can recall from lesson 1 intro, this is where we defined the diff. This diff calculates the difference between neighboring points in the vector. So let's go to help and see. Y equal to diff x calculates differences between adjacent elements of x along the first array dimension whose size do not equal 1. If x is a vector of length m, then y returns a vector of length m minus 1, which means that the result of diff is shorter, one element shorter than the vector y itself, and the difference of x is the vector which is one element shorter than the x itself. And since x and y are the same dimension, y derivative will be the dimension of x or y minus 1. So the length of y derivative will be one element less. And then there is a definition of y, which we see is x2 minus x1, x3 minus x2, and etc. xm minus xm minus 1. So the elements got subtracted, and that is why the resulting vector is one element less, because there are only m minus 1 differences in m elements. So we can just directly see that from running the code, and we can see that x has 1, 2, 3, 4, 5 elements, and y has 1, 2, 3, 4, 5 elements, and y derivative has 1, 2, 3, 4 elements. We should take this fact into account when we plot the derivative. In the first instance, we would want to plot y derivative against x. But the problem is that if we run that, we will get an error because vectors must be the same length in the plot. Error in vector derivative that is in our file lies in line 7 where we have the plot defined. So let's go to the plot help. Either we can press here, or alternatively we can press here, and we will have this help article. And we will read in the description that plot xy creates 2D line plot of data in y versus the corresponding values in x. And if x and y are both vectors, then they must have equal length. Okay, to make them equal, we have to think about where this derivative is calculated, which points is this derivative calculated in. And it's calculated in the first points of x, in the in the amount of points of x which are equal to the length of the derivative. And we can actually say that since x is one element larger than y derivative, then we will have to say, let's take the elements of x from 1 to n minus 1. That is, we will throw one element from the array x. And now this vector has the same length as y derivative. And this plot should work. Let's run, and we see, yes, this plot works. First, we note that we don't have enough points, so we will add points by saying 0.1 from 0.5 to 4, and now we will have a nicer plot of the derivative. Okay, in order to compare, let's also plot the function itself here, which is x and y. So this part will plot the function itself, and this part will plot its derivative, and we'll have two curves. So this blue line is the function itself, and this red line is a cosine curve, which is a derivative of our initial function sine x. But now, as we can see, we cannot directly calculate the number of elements here. We can just see it from what we have in the command window or the workspace. But sometimes we want to know directly what the length of the vectors is, and in this case, we can just use MATLAB function which is called length, and it will show us what is the length of different vectors. Let's say length of x. We want to calculate length of x, we want to calculate length of y, and we want to calculate length of y derivative. Let's run the script, and we see that we have the answers, where first one denotes the length of x, second one denotes the length of y, and third one denotes the length of y derivative. So the length of y derivative is one element, is one element smaller than the length of y and x.